Good morning. Well, hey, I want to start off by trying to hit something that I think really hits home for most of you, which is I'll bet everyone out in the audience has a notebook, certainly a smartphone, and maybe a tablet. And what's key to these devices is that what drives them is transistor technology. And I thought I'd share with you for just a couple of minutes where we are with that technology, why it's important, and I hope to leave you with the thought that we're just getting started in this business. So first off, Intel was actually co-founded by Gordon Moore, and Gordon Moore is famous back for a paper in 1965 that basically said that the industry, and this is really important, it was not just around Intel, but this is something really for the entire semiconductor industry worldwide, that Gordon said he had a vision that the entire ecosystem would be able to double the amount of transistors we can get into an integrated circuit about every 18 months, and hence this was Moore's Law. And in many ways, this is what's really fueled the whole industry, the fact that you all enjoy notebooks, tablets, smartphones, and as I say, you're going to see just shortly, we're just getting started. Now, 32-year veteran of Intel, so when I started in this business, we didn't have PCs. And if you've been around for a while, you remember the first PC in 1981 from IBM. And that had an Intel microprocessor in it. And for fun, I wanted to share with you with the fact that it had a whopping 29,000 transistors. Now, that in itself was huge because the transistor, the first one, was invented in 1949. So just to get 29,000 in one chip in 1981 was huge. Well, where have we come? Well, as you can see, by the turn of the last century, 2000, we were able to get 28 million transistors on one chip. And by the middle of 2000 or 2006, 151 million. But again, what I find astonishing is that we crossed the 1 billion transistor mark in 2011. Now, again, this is true for Intel. It's true for our competitors in the ecosystem. We've all benefited from the ability to put large amount of transistors onto a single die. The benefit is better reliability, better performance, and something very important to the airline industry, lower power, more efficiency. And so for one of the examples, or one of the benefits that's come out of this is you may be familiar that notebooks are on a diet, right? A lot of you that have a notebook that might be 2 or 3 years old, it's well over an inch thick. The notebooks of the future will be about 18, 19 millimeters thick. And one of the real interesting revolutions that's come on is we're all used to using notebooks with a keyboard and mouse. Basically, the entire notebook industry is going through another evolution, and probably around the Thanksgiving time frame as we go into the Christmas selling season, all notebooks will now incorporate touch so that the operating system, just like your smartphone and tablet, you'll have the ability to interact with your notebook either through a touch screen or you can continue to use a keyboard and mouse pad. And I'm going to get into later why this is important and how it kind of really challenges how ecosystem providers have to deal with this rapid change in technology. Now, what really makes all this possible is world-class processor technology. And one of the questions that Intel often gets asked, and in the 32 years I've been at Intel, people asked us, well, do you see an end to Moore's Law? Where can where does this thing finally stop? At least for now, we don't see an end to it. Currently, we are in production with 22 nanometer transistors, meaning that the feature size, a nanometer is a billionth of a meter. It's a real small something, if you could even see it. And basically, this is the size of each transistor. And so what you're looking at is a wafer that we manufacture microprocessors on. And basically on this wafer, and for those that are a little up near the front, you'll see a little yellow piece of tape. But that's the actual size of one of the chips that's basically in your notebook today. And this is on 22 nanometer technology, and we have the benefit, we get about a couple of hundred working microprocessors from each wafer. So we've really seen major inroads. And as I've said, from 1981, we went from 29,000 to over 1 billion transistors, and yet we don't see that slowing down. So, the benefit, by the way, you say, well, should I really care? Well, smaller transistors, smaller channel capacitance, what that really means is less power. and less power is everything. So we're going to see devices that are faster, more complicated, more complex, and yet more energy efficient. So it's a pretty exciting time, and as I say, we don't see any slowdown to this revolution. One last thing, a couple of fun facts. How many transistors can we get on a head of a pin at 22 nanometers? Over 100 million. And if you go back to 1971, one of our first microprocessors, our new processors today run 4,000 times faster and consume 5,000 times less energy. And the cost per transistor has dropped by 50,000 times. So some huge inroads. And again, this is part of the industry, part of the ecosystem. Intel is certainly a proud participant in this space, but it's not unique to us. All right, so let me kind of change the direction a little bit. And I want to discuss some of the parallels. We have had a pretty long history at Intel in supporting in-vehicle infotainment. And I think that, you know, while there are some parallels, I'm not going to say it's an exact overlap of market needs. I want to share with you some of the successes, some of the challenges we've overcome in this space. And I think they would be very appropriate to the aviation industry in terms of some of the challenges that you see ahead. So first off, at Intel, while we have this fantastic silicon experience, we also have another saying in the company, and that is silicon without software and applications is just heat. It has no benefit. Nobody ever bought a notebook for our microprocessor technology. They bought it to get something done, to have a utility, to have some end user benefit. And so we have a lab that's actually set up to try and understand and anticipate the needs of user experiences, interactions, and more, for example, would you believe that a company like Intel has anthropologists on its staff? And the reason is that really understanding how people interact and what their needs are with technology is absolutely critical. One of the challenges that we have is that today we're at 1 billion transistors. Shortly, 2, 3, 4, 5 billion transistors on a chip is certainly within sight. But the real question is, what do we do with that extra couple of billion transistors? What needs does the market have? If we do it right, it's a winner, but if we do something wrong or we go the wrong direction, we could certainly miss the needs of our community. So we're very much trying to understand, and some of the biggest challenges is anticipating what are the user experiences. Certainly things like social networking today have a lot to do with how we're trying to design our products in the future. So what I want to share with you a little bit is where we see the connected car. And I think you're going to see that the connected passenger, that there's some of the same things. And what we see is, first off, seamless device integration. And I'm going to get more specific later about why this is important in the fact that people simply want all their products to work together. And also, be able to have connected applications, applications that work with each other, and the ability to be location-based services. Whether you're in a car or an airplane, that's probably a different set of needs than sitting in your living room or in work. And the application and the user experience should reflect that change. And then again, as I've said, energy efficiency is absolutely everything. And by the way, for everyone that's got a notebook or a tablet or a smartphone, behind that, when you're basically doing something cool like social networking or buying something on Amazon, on the back end, you're talking to a server farm. And some of the largest energy consumption in the United States is around servers and server farms. And it's almost, when you see some of the numbers, it's quite daunting to see what it takes to run that. And one of the things that we see is, again, this demand for more cloud-based services. The back-end energy consumption that it takes is quite large, and hence the ability to make very cost-efficient transistors and provide hardware on the back end that's energy efficient is very, very important to the success of this industry. All right, what I want to talk about next is Tizen. And Tizen is something that I think in the automotive industry, the aviation industry could take a page out of this and consider it. Tizen is an open source Linux. Now, it's being held by Intel, but it's not a profit center for Intel. It's an open source software solution that we make available to the industry. And the whole benefit of this is to get collaboration among the ecosystem so that everyone has the ability to mix and match and be able to work in an open environment. And we absolutely are committed to open source software. Probably one of the most important trends that's going on, and if you're in the buying side of home, or I should say in entertainment capability and in the aviation space, is you want to become very familiar with the capabilities of HTML5. Long story short, HTML5 will be the new language of the World Wide Web. And it will absolutely allow for multiple devices of different architectures, different vendors, different companies. They will all be able to work and interact together in a seamless environment. How many people today maybe have had an Apple iPad and wished you could have ran a Flash? You go onto a website, and all of a sudden you find out it's based on Flash and it doesn't work, or you have to go download an app that gets around that so that they can have that experience. That all goes away with HTML5, and for the record, Apple's on board as well. So, long term, I think we do see some convergence in the industry. We think that's good, and we foster it. And that was certainly something in the in-vehicle infotainment space in the auto industry that they insisted. They didn't want to get into a proprietary, what we often call a walled garden type approach where they get stuck. And so getting into open standards, open source software with new applications written around HTML5 really does open up the industry, allows the best players to compete, and at the same time allows you to maintain your investments over time. Now, you may be familiar with something called the Geneva Alliance. This was founded in 2009, and again, I would welcome the aviation industry to consider a similar approach in terms of in-flight entertainment. The idea around the Geneva Alliance is that it's a nonprofit consortium, and as you can read up there, to establish a competitive Linux-based operating system, and again, Tizen being one example of that, middleware and platforms for the automotive industry. And like anything else, it's 2009. It started off with about 100 members, and as I'll point out, we have a very strong ecosystem today that's really creating a much more richer user experience. One of the problems that we often have in this space is the rapid change in technology. I mean, can you imagine, 3-4 years ago, tablets didn't exist. Yet, how many airline passengers are likely to have a tablet in their briefcase? Pretty high number. And so to anticipate some of these needs of the industry, you need an open, flexible architecture that's going to allow you to see some of the changes. And as I pointed out, we're not slowing down. Our competitors are not slowing down in the semiconductor industry in terms of creating more value in the semiconductor hardware technology. So the benefits of Geneva is to really work with the industry in the automotive space to collect the needs, develop open references and open specifications, and then basically we let the best companies win. And it's a pretty good model, and it's working well. And again, one that I would definitely want to share with the aviation industry. And what's also very important, and I've said this before, which is we want you to start with a software platform that is basically open and will allow it to be automatically updated but not become obsolete. Because it'll be impossible to put something in an aviation or an airplane today that's going to meet the needs of somebody 5 years from now. But if you have a flexible open architecture with open source software that everyone can write to, that can be an evolving ecosystem that can absolutely mature just as the industry does with new capabilities and new technologies. And typically, we think it's on about a 2 to 3 year cadence when, at least in the in-vehicle infotainment space, that the auto industry will have the ability, even for cars already sold, to go through updates and allow this platform to transcend on new technologies and new capabilities as they become available. So in summary on the Geneva Alliance, today we're at over 160 members, 10 automakers, 19 suppliers, 17 silicon players, and just about all major software and service application groups are there. So it's been a very strong ecosystem, and as I say, the benefit is it benefits everyone. And I think that's really, what we've seen with open standards and open capability. Now, one of the things I wanted to bring up is in the IT space, and so I regularly work with companies, New York City, some of the big, investment companies, as well as insurance, a lot of hospital management. These are all driven by very large, centric IT shops. And the new buzz today is bring your own device to work. If you look back 6, 7, 8 years ago, this industry was dominated by the IT department giving you a notebook or a desktop computer and pretty much locking you in to their vision of what the world should be. And for both economic reasons as well as people wanting to have more flexibility, they want to be able to bring their own devices to work. And certainly the notebook will still stay, and as I pointed out, we see the notebook going through kind of a metamorphosis. It's getting thinner, lighter, faster, will now be responsive to touch. And yet at the same time, a lot of people are very enamored with their tablets as well as smartphones. And so more and more, what the IT departments are finding out is that they have to be able to work with all these devices seamlessly. And a great analogy was, if you go back to the old car phone, 15 years ago, we had installed car phones. Well, quickly, once the phone itself became smaller, well, we've gone to the Bluetooth model, right? You get in the car, and the car seamlessly pairs up with your smartphone, and off you go. Well, that's clearly where the IT departments want to go, and perhaps the aviation industry as well. There's a lot of people coming on board with devices, and what's really important is that the devices that they're going to come on board with, say 5 years from now, I can't tell you what it is. We know that they'll have tremendous technology available to them, but as I say, when you see where we are today with tablets, and it's only been 3 years, you look at what's going to happen in the next 4 or 5 years, it's impossible. Hey, if you can do it, let me know. I'd love to be able to see the future. And certainly at Intel, we try. But it is a really, really tough thing to do. And so all you can really make available today is an open architecture. You've got to put something in the place that's going to grow and scale with a constantly changing environment. That's the only thing that's constant, is the fact that this technology is going to churn, it's going to evolve, and it's going to create bigger demands on the end users. And what is interesting is that if you think about it, an airplane is basically, it's a flying city, especially when you talk about some of these large, multi-passenger, multi-deck airplanes. And it's a flying ISP, it's a flying internet service provider. And you're not always going to be connected all the time. And so there are some unique challenges in this space. And so number one, the aviation industry is going to see more users. Certainly the density of the airplane and the number of people is going to grow, and challenges with that. More devices and more data. And I can tell you, I could do some other presentations, but there's nothing growing faster than data. It is on an exponential tear, and of course, what we call big data, which is the type of data like video that's often you see in YouTube, the amount of data that consumes is huge. And so the whole storage industry is going through a real revolution. So one of the technologies that we offer is every airplane is going to need a server. And it is a basic flying internet service provider. If you have connectivity and it's there all the time, great, but that's an unrealistic expectation for the aviation environment. There will be times that the airplane will have to rely on its own in-house, in-compartment capability to supply content and data to its users. You're definitely going to need some type of on-plane server. And I can say that in the Moore's law of more and more transistors, the server technology is also equally benefiting. And again, not something you see as much, and maybe not quite as sexy as the tablets, but it's what gives those tablets value. And so the back end of the server space is equally scaling up. And one of the things, again, is there's a lot of computational power that's needed to deal with a lot of the different formats and capabilities so that we can make this seamless. Somebody coming in with a smartphone will need perhaps a different level of data than someone attaching on with a tablet or a notebook. And you need processing power on the airplane to be able to adapt to the changing needs of the devices that people are going to bring on. Now, again, if you've been around the industry like me, you remember hard drives. Well, I'll tell you, hard drives are just about history, and I'm not going to miss them either. If you've ever had a hard drive crash and it's only a matter of time. It ain't pretty, a couple of gigabytes of data, and it never happens at a good time. Where we see the industry, and again, not just Intel, but the industry, with the advances of Moore's Law, we can use semiconductor memory, basically using what we call SSD. These are basically semiconductor static memory devices that allow us to store information just as we would do on a hard drive, but it's done with all the reliability that you get in an integrated circuit, but even more important, much, much better performance at price per bits that are lower than in the hard drive space. And the reliability of these devices, easily 10x. I mean, it's as good as anything you've seen in the standard microprocessor and semiconductor technology. So again, in building an open system, the advances in semiconductor storage technology ought to be a very welcomed opportunity for the aviation space. And then lastly is security. And what I really want to kind of both warn you and give you some advice is Intel acquired a security company, McAfee. But regardless of whether you look at us or anyone else, any solution that you deploy, security has got to be front and center to how you ultimately build a scalable system. There are bad guys out there, and they want to take us down. And let me tell you, they're as real as anything out there. It's a constant source of concern. 10 or 15 years ago, we built a microprocessor with one goal, and that was to make it faster, more performance, more capability. Today, we have to look at a new feature, and then the next question we ask ourselves, is that feature secure? Can we guarantee that a hacker can't take advantage of that capability? Security is actually very much integrated into how we design products, and it's both at a hardware level, and then we complement that with software. And so as you look at solutions, and as I say, the plane being a flying internet service provider, server technology, storage technology, and security have got to be some of the key pillars that drive your decision process. Now, what's really cool is that, as I said, we can't anticipate the devices that people are going to want to use in the next couple of years. But what we have seen is that detachable devices are the next big thing. We just indicated that notebooks today are thinner and lighter, but very shortly, a lot of the notebooks will allow you to take the screen off and then use that as a tablet, and then you can marry it back up if you want to use it in a keyboard mode. The point is, more and more people are going to want to bring these devices onto an airplane and would like to continue to have some level of connectivity, would like to have some ability to get content, entertainment, and that capability really resides on the ability of the aviation industry to build that into the cabin. One of the interesting questions comes up is, what about intellectual property and protection? And again, just as with security, it's a big challenge to the whole entertainment industry. Can I guarantee that if I put something out there and make it available from content, will it be secure? There's many solutions out there. One today that Intel has is called Intel Insider. And to give you a little more specifics, that slide didn't make it in, but let me go back. The Intel Insider is a capability that allows for end-to-end hardware encryption that will allow premium content. And so we've been successful with several of the distributors and movie studios to consider this encryption to be sufficient for first-run movies. And that's been a big step forward. And the ability of this technology is not only can it stream, but it could also allow you to download. So, very simply, someone could come on the airplane, pair up a device with the onboard server, and then have the ability to download that movie and watch it once. And perhaps they watch half of it on the airplane. Maybe they want to finish it in their hotel room. Maybe they buy that movie right before the airplane lands. But it would give them that seamless flexibility of being able to make a purchase, have an entertainment experience, but it would still be very consistent with their own ecosystem, their own devices that they've brought on board, and allow them to have the same experiences that they're used to in their own living room. So fundamentally, as I wrap up here, we really see the world as one big universe of gadgets and capability that we want to try to tie together. And certainly the aviation and the aircraft fits in very nicely with that overall system. As you can see, everything from TVs, notebooks, intelligence systems, gadgets, there is a full ecosystem of products that are out there that people no longer want to work as individual devices. The success of these devices going forward is their ability to integrate, work together, to share data, and to operate seamlessly in different environments. And we're at Intel very committed to that. It's not about just building a good notebook or building devices into smartphones and tablets, but rather going a step beyond that to make sure that these devices all interact and create some type of a total experience that is better than just the sum of the parts. And in the center of all of this is servers. And as I say, that's an area that continues to grow and benefit from Moore's Law. And every time somebody, we see another 1,000 iPads being sold or another 500 smartphones, the demand that that's putting on the back end in the server space is quite huge. And on one hand, it's very nice, creates a nice opportunity to sell some hardware. But on the other hand, it really creates demands for power efficiency, and the ability to do something in a secure fashion. So security among this entire ecosystem is absolutely critical. All right, that's basically the overall Intel message. And with that, thank you.